Okay guys, I'm going to make a video for you helping with some of the problems that many people got wrong on the quizzes that were assigned today. So first we'd like to talk about number 5. Number 5 asks for you to write the standard form of a circle. This is completely an algebra-based problem, so if you wanted to more focus on the circle properties, you can go on and fast forward this question in the video. Otherwise, pay attention and we'll go over how to do this. Now remember, standard form is x minus h quantity squared plus y minus k quantity squared. That equals the radius squared. So notice we have a binomial that is squared here and another binomial that is squared here. So, but when we're given this equation, we do not have it written in that form. So the x squared is okay, but this is not something that we can rewrite in parentheses like this. We can only do that by completing the square. Okay, so in order to complete the square, what you're given is y squared plus 10y. We can add a term to this trinomial that will make it a perfect square trinomial. And when you have a perfect square trinomial, then you can rewrite it like that, because that's the factored form. Some of you are just starting factoring or just finished up factoring algebra, so this may be challenging, but just pay attention and I'll go through it. So in order to make this a trinomial, we need to add a term right here. The term that you're going to add is a term that is half of the b term, so half of 10, and you're going to square it. So we're going to do 10 divided by 2 and square it, and we get 25. So therefore, if I put plus 25 at the end of this trinomial, I could rewrite it as y plus 5 quantity squared, because that's the factored form of this trinomial. That's great, but the only problem is if I added the 25 to the left-hand side of the equation, the original had a 39 over here. We also need to add a 25 to the right-hand side of the original equation. So once we do that, now I'm going to rewrite this right here, y plus 5 squared equals r squared. The other side of our equation is 39 plus 25, which is 64. And that is how we get letter B as our answer. Okay, so you have to complete the square. And the way you complete the square is by taking half of the b and squaring it and adding that term to both sides of the equation. Then rewrite the trinomial as a binomial squared, and then you can rewrite it in standard form. Okay, another problem that gave people trouble was number 9. Number 9, we're trying to find the length of this tangent. So if you recall, the property is that the tangent squared equals the external part of the secant times the whole secant. The whole secant in this problem is 20 because it's 5 plus 15. So x squared equals 100, which means that x equals plus or minus 10. Remember, we don't use negative values for lengths, so our answer is just going to be 10. For number 10 on this sheet, we have two secants. We have a secant here, it passes through the circle, and a secant here, it passes through the circle. Now, they're asking us about the lengths of the parts of this. They're not asking us about the arcs. So the property for that is that the external part times the entire secant. What is this entire secant right here? There's a variable, so we can't combine those terms, but we can represent it by 8 plus x. Okay, so that's going to equal the external piece of the other secant, which is 7, times the entire secant, which is going to be 16. Okay, so now we're just going to use some algebra, and we are going to distribute the 8. 7 times 16. $112. We're going to subtract the 64 from both sides. And that's how you get x equals 6, letter A. Okay, this problem gave people a lot of trouble. In some of the lessons we did before we left for this, remote learning, we found the length of the sector. In this problem, they're asking for the area of the sector, but you follow much of the same process. It is that the central angle over 360 is proportional to the area of the sector over the area of the circle. Okay, so what that means is I'm going to rewrite the area of a circle as pi r squared. And our central angle in this problem is 120 degrees. So our radius in this problem is 4. So I'm going to do pi times 4 squared. So in order to solve for the area of the sector, we're going to multiply both sides by 16 pi. So 16 pi times 1/3 is what you get when you reduce that fraction, equals the area of the sector. And we can rewrite that as 16 pi over 3 feet squared, because that's our unit and we're dealing with area, so you have to have feet squared. Okay, this is a very special problem, and this always, every year, seems to confuse students, so please make sure you pay attention. This is a special property that you should add to your knowledge bank. It is that when you have two tangents, both of these lines are tangents, tangent, tangent, you have a special property. When two tangents meet outside a circle, the angle formed, in this case, angle BDA here, or ADB as they're asking in the problem, is supplementary to the minor arc it intercepts. The minor arc in this case is here. So we know that the yellow arc and the red angle are supplementary. Great. So if we're trying to find out the angle, we're going to need to know what this arc is. Very easy to figure that out. Together, this arc that we're trying to find and the 265-degree arc form a 360-degree circle. So you just do 360 minus 265. And that will give us that our arc right here is 95 degrees. So, therefore, 95-degree minor arc plus our angle equals 180 degrees, leaving our intercepted arc to be, our angle ADB is going to be 85 degrees. Okay, letter B. Okay, number 16, I'm not sure why this gave people trouble. The rule is that when you have two chords crossing in the middle of a circle, they form two arcs, this arc and this arc. Angle ABD, this angle right here, and this angle are vertical angles, so they're both going to be the same thing. The way that you find out what the value of each of those is by adding 65 plus 37 and dividing it by 2. And you'll get 102 divided by 2, and that's how you get that angle ABD is 51 degrees. Letter B. Okay, down here, 21. They are asking us for arc RT. When they're asking you for an arc, we know that all of the arcs in the circle add up to 360 degrees. So we are going to have to find the 166 plus this arc and subtract it from 360 to get our remaining piece that we are trying to find. So how do we find out what this arc is? Very simple. The angle that forms it, as long as the vertex is on the circle, which it is, the arc that it intercepts is double. So this arc is 142 degrees. So together we have 166 degrees plus 142 plus arc RT will give us a total of 360 degrees. So 166 plus 142 is 308 plus RT equals 360. And get RT equals 52 degrees. Okay, next we have this problem. Now this is asking us for angle BDC. This is a secant and a tangent. It doesn't matter as long as two segments are meeting outside of the circle. We take the difference of their intercepted arcs. So we are going to take this arc minus this arc and divide it by 2, and that's how we get that angle BDC is 40 degrees. Okay, now in this problem it's asking you the same exact thing. It's asking you for an angle that is outside of a circle. If it's on the outside of the circle, you take the two arcs that it intercepts, which is 178 degrees, and the other arc that it intercepts is 102 degrees. You find the difference of those two and divide it by 2. And that will give you, I think, I don't know, 178 minus 102. 76 divided by 2, we get 38 degrees. Okay, so when the intersection's on the outside of the circle, you subtract the two arcs that it intercepts and divide it by 2. Okay, hope that helps. Let us know if you have any other